Okay, in this lab, we're going to be looking at temperature changes in reactions to be able to determine if a process is exothermic or endothermic. Before we get to that, let's review the first law of thermodynamics, which is also known as the law of conservation of energy, which states that the energy in the universe remains the same. It does not change. The energy in the universe does change from one form to another. However, the energy total that we have in the universe, it will always be the same. It cannot be created nor destroyed. Now, with that said, when we look at different processes or different experiments or reactions or whatever it is that we're looking at, we want to identify things as the system, the surroundings, and the universe. Now, the system is always your focal point. What are you looking at? What are you studying? So if we're looking at a reaction today, the reaction itself will be considered the system. Anything outside of that is considered a surroundings, and obviously when you put all those together and you add them together, that will give you the energy of the universe. So when we look at today's reactions, we're going to be mixing different things, and keep in mind that the reaction itself is a system. The energy transfer in and out of that reaction into the surroundings is what we're going to be measuring the temperature at, and that's what we're going to be looking at to be able to determine if we have an exothermic or endothermic process. Now, in terms of the system, when energy leaves the system or the reaction into the surroundings, well, then it's going to feel hotter, it's going to feel warmer. And so when things leave into the surroundings and it feels hotter, we call that an exothermic process. Exo, like exit, heat is leaving the reaction into the surroundings. We're going to be measuring temperature changes. That is called an exothermic reaction. Okay. Now, the sign convention for the surroundings, since it's receiving the heat, the surroundings are receiving the heat, it's going to be a positive value. For the system, it released that energy, and so that's going to be a negative value. So whatever the system leaves is equivalent to whatever the surroundings are gathering. So the surroundings will be a positive value for that. Now, if we do the opposite, what happens if the surroundings, its heat energy is absorbed into the reaction? It's going to feel colder on the outside. The surroundings are going to feel colder. So when it feels colder, that's called an endothermic reaction. An endothermic reaction is also going to be a negative value. The temperature is going to be dropping. Okay, you're going to end up with a negative value because that heat energy is being lost to the system. It's going to be absorbed into the system. So therefore, the system is receiving all that energy, and it's a positive value for the system. So keep those in mind. Now, for the setup of this experiment, we are going to have to be using some type of an isolated system. Now, just to recap the following, an open system is any container where you can basically get rid of matter, okay, or heat. Heat and matter can actually leave. Now, for a closed system, it's any substance that is closed where matter cannot leave, but you can still heat it up. Energy can still come in and out. So energy can still be transferred. However, an isolated system is something where neither heat or the matter can leave. So everything is trapped inside. So today we need to use some type of an isolated system. It's not going to be a perfect system, but we want to use that so that we can ensure that the heat in the reaction, whether it's absorbed or released, is not lost, and we can actually measure those temperature changes. So for this experiment, we're going to be using a coffee cup calorimeter. Coffee cup calorimeter, we're going to put a lid on it, and we're just going to basically put a tiny hole to put the thermometer inside and be able to record those temperature changes as the reaction is occurring. So this is also known as a calorimeter. It has that word calor, or heat, and we're measuring the heat changes inside this chamber or this isolated system so that we can determine if we have an exothermic or endothermic process.